Go ahead, Ashley.
Hello, everybody. Welcome to our next session, number 119, where we'll be covering pop stats where fandom meets functions. Our first speaker is Tristan Bullock. She is a post-bac at Smith College and did her undergraduate degree at Wake Forest University. Take it away, Tristan.
Hello, let me share my screen for you guys. All right. Okay, hi everyone. My name is Tristan, and today I'm presenting my survival analysis project based on the Hunger Games. I applied Kaplan-Meier and Cox proportional hazard models to explore which factors like sex, rank, and age influence survival among tributes. Oh, it's not doing the scroll. Hold on. Sorry, I'm going to try sharing a different part. Sorry. This might be better. Okay, I'll go ahead and do that. Okay, so for anyone unfamiliar, the Hunger Games is set in a dystopian world called Panem, and each of the 12 districts in Panem must send two teenagers to compete in a televised fight to the death. The last person standing wins, so in a way, it's an ideal setup for a survival analysis problem. The Hunger Games gives us a clear survival framework. Each tribute starts at time 0, which is going to be the beginning of the games, and either experiences the event, which is death in this case, or survives. Our primary objective was to analyze overall survival patterns and determine whether survival times differed based on character attributes like sex and rank. So some background for data collection. Our data was collected from the first Hunger Games movie. We used all 24 tributes, so it's not a sample, but the full population. We included variables like survival time in days, sex, age, and rank, although Alliance had too much missing data to be used. Our covariates are sex, age, and rank. We've coded sex for 0 as for male, 1 for female. Age was summarized by its mean and standard deviation, and rank we treated as a categorical variable since multiple tributes shared the same rank. Most of the tributes had rank 14. Some demographic information. On average, tributes were about 15.8 years old, evenly split between male and female. Ranks ranged from 1 to 14, with multiple tributes sharing the same rank. So some shared rank 1, some also had rank 14, and the average rank was around 10. And just to show the range of ages, the youngest character was Rue, age 12, and the oldest character was Kato, age 18. Here's just a visual look at the data that we were working with. It was a very small population, obviously, since there was only 24 characters. But on the left, the blue graph is just the number of characters by sex. So it makes sense that there's 12 in each because there was 1 male and 1 female from each of the 12 districts. And then on the right is the number of characters by sex and their survival status, which also makes sense. If I'm spoiling the movie, I'm sorry, but Katniss and Peeta were the 2 that survived, so it makes sense why there's 1 in each column for male and female. Here's a visual look at numbers of characters by rank, and as I was describing earlier, a lot of them have rank 14, and Katniss and Peeta were the ones with rank 1. And the ranks are done by when in the movie where they were supposed to show their strengths or their certain things that they were good at, and this was when Katniss shot an arrow into the apple of the pig, if you guys remember the movie. Number of characters by age, and this makes sense when looking at this graph why the mean was 15.8, as most of them were age 15, but most of our data ranged between 15 to 17 years old. Our statistical analysis plan, we began by using Kaplan-Meier curves to estimate overall survival, and then we used a log rank test to compare survival functions between the sexes, and we used Greenwood's formula to create confidence intervals. We then fit a Cox proportional hazard model with sex and rank as covariates, using Wald's test to generate confidence intervals for those hazard ratios. And all of this was performed in R. Here is our Kaplan-Meier survival curve separated by sex. The red curve is going to be the male and the blue is going to be the female. So visually you can see that males appear to have a slightly higher overall survival and their confidence interval remains somewhat higher throughout the event timeline. But to confirm whether that this difference is statistically significant, we used a log rank test. And our log rank test statistic was 0.045 with a p-value of 0.83. Since this is well above 0.05, we failed to reject the null hypothesis. So there isn't sufficient evidence to suggest that male and female tributes differ significantly in survival time, which when you think about this logically makes sense since both Katniss and Peeta survived. Next, we used the Cox proportional hazards model to include both sex and rank, and the baseline group here will represent a male tribute with rank 1. And from the forest plot, we can see that the confidence interval for sex includes 1, suggesting it's not statistically significant. However, rank has a very strong relationship with survival. The p-value for the Wald test that we performed was 0.0006, indicating we can reject the null hypothesis and conclude that rank has a significant effect on hazard of death after adjusting for gender. So a way to look at these confidence intervals is saying that we are 95% confident that the true hazard ratio for male versus female after adjusting for rank is between 0.41 and 3.5. And this interval obviously includes 1, so we cannot conclude a statistically significant difference in hazards between males and females. But then for rank, we are 95% confident that the true hazard ratio for a 1 increment increase in rank after adjusting for sex is between 2.15 and 16.38. This entire interval is greater than 1, which indicates a statistically significant association. So a higher rank, which means a lower scale or strength, is associated with a higher risk of death. For a secondary analysis, we extended the Cox model to include age, with the baseline being a 15.79-year-old male at rank 1, so we used that mean age. Adding age didn't change the pattern much. If you look at the forest plots, sex and rank remained similar, and the age's p-value was 0.35, which isn't significant. So age doesn't appear to have a population-level relationship with hazard of death. And a way to look at this is that we are 95% confident that the true hazard ratio for a 1-year increase in the character's age, adjusting for gender and rank, is between 0.59 and 1.2. And again, since this confidence interval includes 1, we cannot confidently say that age has a significant effect on survival. The association might be non-significant or weak. So just a summary of this, we found that rank significantly predicts survival. Higher rank corresponds to a higher hazard of death, which, if you think about it logically, makes sense. If you don't have a great ranking, then you're probably not going to survive as long. And sex and age were not significant predictors. The biggest limitations is the small data set. We only had 24 observations from this movie, and we also were missing some data from variables like alliance, which limited what we can include. And when you think about alliances, could be very important in someone's hazard for survival. If we were to extend this project, we'd incorporate variables like district or alliances, which might explain more of the variation in survival. We could also expand the dataset to include tributes from later films to strengthen the analysis, especially the second film, since they bring back all the winners of the old seasons. That could be a great comparison. So thank you so much, and I'd like to thank Dr. Lotspeich for allowing me to present today.
Great job, Tristan. And you read the audience's mind. Annie had asked you if you had tried analyzing the sequels, which you mentioned as one of your future directions.
Oh, yes.
Wonderful. So our next speaker is Ashley Mullen. Ashley is a PhD student in biostatistics at Vanderbilt University. I'll let you share your screen, Ashley, and take it away.
Hi, everyone. Can you see and hear me okay?
Yes.
Awesome. So today I will be chatting about talking over a football game, the Taylor Swift effect on football podcast popularity, or as I like to call it informally, statistics all too well 10-minute version. And bonus points to anybody that figures out how many Taylor Swift jokes there are in these slides. I like to always give the audience a chance to follow along with my slides if that's something they're interested in. Take a moment to scan this QR code. It'll take you to my website, and this will be talk number 2 in the coming soon to theaters. I'll give you all about 10 seconds if that's something you'd like to do. Cool. So to get started, I will be talking about a little bit of background on this problem that we're cooking up here, a couple of methods on how we're going to address it, some results, and a final takeaways I'd like to leave you with. Let's dive into the background. So folks that are in this room probably know who Taylor Swift is, but just in case, I'll give you a little background. She began releasing songs in 2006 on her self-titled album, Taylor Swift, which kind of lived in the country sphere. And she is just getting more and more popular as we go on in the last about 20 years. As of 2022, she was the first artist to win 4 Album of the Year Grammy Awards, which is super cool. And her most recent album was her 12th, The Life of a Showgirl, which recently dropped on October 3rd, 2025. Now, as a public figure, Taylor's dating life sometimes happened to come into the public sphere, and this is actually what's causing the question of interest here. She began dating and is now her fiance, Travis Kelce, a tight end for the Kansas City Chiefs in 2023. And Travis and his brother, Jason, who is a retired center for the Philadelphia Eagles, these are both American football teams, they began hosting a podcast together, New Heights, which covers a bunch of sports related things, in 2022. And to promote her upcoming album, Life of a Showgirl, Taylor appeared as a guest on the New Heights podcast in August 2025, specifically the 13th. So, as someone who took a little look at that podcast, I had a couple of questions. The first was, how did Taylor's appearance on the podcast affect the popularity of the podcast? And number 2, how did her appearance on the podcast affect the popularity of her upcoming album? So let's talk a little bit how to measure these things. First, we're going to need to define popularity. In this case, we measure popularity with Google Trend scores, which basically take the number of Google searches of a specific keyword and they standardize it to max out at 100. So I tracked the keywords New Heights to represent the podcast for that first question, and Showgirl to represent the album in the United States for 2 months before and after the appearance. And the data I was able to get was basically that standardized from 0 to 100. Now, to model the effect of this specific incident, we're going to take a little side tour into the world of causal inference. We use an interrupted time series model to take a look at the impact of this New Heights episode, specifically the interruption, on patterns in album and podcast search trends. So what that's going to look at is it's going to see, okay, what were these searches looking like before Taylor's episode? And then it'll say, okay, what would it look like in the alternate universe where Taylor did not appear on the podcast, which is what we might call a counterfactual. And then it quantifies any change that we might observe. And because folks that know a little bit about linear regression might know, one of the things that we assume is that each data point is independent, meaning that a Google search from one day to the next is not going to change the search on the next day. But since that's not quite accurate in real life, and if folks are Googling something on Monday, they'll probably be Googling it on Tuesday, we use a correction to the standard error from the linear model, the Newey West standard error, to generate the 95% confidence intervals to adjust those standard errors a bit. So a little bit more on this specific model, I'd like to point you to the bottom of the screen where we examine our linear model. We're going to estimate the predicted trend, that outcome of the standardized Google search score, and estimate a baseline pattern. Then that beta 1 is going to be the pre-Taylor trend pattern, so what's going on with these Google searches. Then we're going to look at that beta hat 2, which is the jump that we can attribute to the Taylor episode. That'll work together with the original intercept. And then beta 3, which is going to be that adjustment to the pre-Taylor trend pattern. If you add that up to beta 1, then you're going to get that new slope so we can look at the new trend. Okay, let's see what that looks like. So the first one that we're going to look at is to answer that first question, what's going on with the New Heights keyword search term before and after Taylor's episode? So in the green is days before Taylor appeared, and it's a slight upward trend. And it looks like we've got quite a bit of a spike going on both sides of that 0, meaning Taylor's episode in both the green and the orange. And that dotted line that continues from the green trend is what the world would have looked like if Taylor never went on the episode. That's our counterfactual. But it looks like we've got a little bit of a change in direction as we move towards the 60 days post the episode. And for folks that were following the album, it showed up right before 60 in that little gray arrow. Now let's take a look at searches for the Showgirl term. we've got a little bit of a slower growth towards the Days of Taylor episode. And we can see that dotted line continuing the counterfactual in that alternate universe without the Taylor episode going up really slowly. But we see a big difference. It's starting to pivot up a lot faster as we go past the episode and into the days closer to the album. Now let's put a couple of numbers on that. So I'd like to point out a few things in this chart where we basically summarize the estimates and the 95% confidence intervals. Now these numbers are a little bit less important for a point estimate because we have this outcome being standardized rather than counting direct Google searches, but the direction is really important. So I'd like to highlight specifically the things that I highlight in white. The trend pattern is that we've got a positive estimate and that confidence interval is keeping us in the positive zone, meaning that before the episode, the New Heights search was going up and that it actually went down with that negative coefficient towards the bottom after the podcast. And on the Showgirl side, we additionally have, again, that positive. We've got slowly increasing as we move towards Taylor's episode. And we actually have it continuing to increase even more with that positive beta 3 adjustment to the trend pattern after Taylor's episode. So a couple of takeaways that I'd love to leave you with. We observe, again, those increasing trend scores in the 2 months before Taylor's episode on both the podcast and the album, but we have different effects. And if we look after the episode, for the podcast, it'll be decreasing in trend scores, and for the album, it'll be increasing even faster. And in summary, because we can see these jumps that are statistically significant at the 95% level, we know that Taylor Swift is a woman of influence. Here are a couple of references, both on Interrupted Time series and everything you ever wanted to know about Taylor Swift. And thank you. If this is something you're interested in, here is my contact information. And it looks like I have a minute or two to take any questions.
Folks can drop questions in the chat. I have a question as a person who doesn't know enough about Taylor Swift. Your second graph, so the Google trend in Showgirl, was it Showgirl? Or, sorry, one of your trends had a bump. It's actually, I think it's New Heights. Sorry, the last one. What is the bump like at day 15 post her appearance? You're muted.
I'll be honest, I actually don't know. I'm less of the sports fan and more of the album fan, so I could probably answer things in context better on this one.
Okay. Oh. And
So I know
asked
that
if that's her
spike is going to
engagement.
be the album. That probably would be the engagement. I would have to double check exactly if that's living around the 15-day mark.
We do have a question on Wayne wants to know, would the effect be even greater if we don't account for the anticipation of her going to be on the show?
That's really interesting. I feel like if we had an extra variable in the model, we could probably control for that. But in this case, we're just looking specifically at the episode only, and we're tracking time. And yes, I'm seeing in the chat, her engagement is probably the correct answer.
Awesome. We have time for one more. Well, thank you, Ashley. Lucy, do you want to queue up your slides?
Yes, I do.
Excellent. Our last speaker is Dr. Lucy D'Agostino McGowan, who is an associate professor of statistics at Wake Forest University in the US.
Oh, thank you very much. Okay, I am going to share my screen in 1 second. Okay, here we go. This one, yes. I need to make it big. All right. Hold on, sorry. I need to make it big first. It's like not letting me make it big unless I share it. Okay. Sorry, the like Zoom thing is right in front of where I want it to be. There. Okay. All right. Thank you very much for the intro, Sarah. I am excited today to talk about some data curation that I have done for a, in my opinion, popular TV show known as Severance. I think this is an example of how you can kind of allow for your deep interests to also inform your work. So I have enjoyed the show Severance since it came out in, I guess the first season was 2021 maybe, and they recently had a second season in the spring, and I have been kind of curating some data sets from this TV show, so I thought I would just talk a little bit about that. Okay, so the sources. I compiled data sets from kind of three main sources from this show. The first were the transcripts, and then I compiled a little bit from the audio, and then I pulled a little from the visuals as well. So I'm going to show a couple examples of those over the next 10 minutes or so. Okay, so for the transcripts, after each episode, I basically scraped the transcripts and then added them to this R package, which I linked to in one of the later slides, but just to kind of show a little bit of what that looks like. So this is what one of their transcripts would look like raw, where it's like written in, this is actually for a wiki, that's where this is scraped from. There's a wiki Severance page where they would pull this, and so it's sort of a combo of HTML and wiki language here. So this example was from season 2, episode 9. And you'll kind of notice that there's like some clear way, you can sort of figure out some pieces from this data that you could extract. So for example, here, you can see that like at the beginning, the character Helena says the word father, and then the character James says a momentous day. And there's also timestamps here that you can extract. So I scraped this text file in from the wiki. Initially, this was done all programmatically, and then about like halfway through the second season. So the wiki, this is one thing when you're kind of pulling data from any sort of source like this, there's occasionally, you want to make sure that you're allowed to scrape the data, and that is not always true, but this particular site does allow for you, the license allows for you to scrape from it. So that's what I was initially doing, but then about halfway through, they employed some like Cloudflare-ish thing that was not letting me scrape anymore programmatically, but it's not so bad since there's like an episode a week. I could just like go and manually pull the text for the couple of weeks that I had to do that. So just to kind of show very briefly kind of what the kind of cleaning up the transcript would look like is just some pretty basic regexes to kind of pull out the dialogue and pull out the timestamps and then put it in a nice, neat little data frame that then I could analyze. So that data I used for a couple different analyses, so I thought I would just show a couple of them in case that's of interest. So for example, I did this analysis, which just looked at, so these radial graphs I think are so fun, and very rarely do I get an opportunity to use a graph like this, because it turns out it's like not a great way in general to represent data, because like the amount that it counts kind of increases as you get higher. So like this looks like way bigger than like this down here, even though both of these were, like not so different in terms of the amount of words that were stated. And so this is like an issue with radial graphs, but can be kind of fun for a nothing analysis like this. And so this is for every episode. This just visualizes who is speaking in each of them, which I think can give you like a kind of an interesting sense of what's happening in the show. So like the main character, Mark, here is in blue, and you can see he's got a lot going on in season 1, episode 1. But then by season 2, like Dylan starts to kind of come in more, especially towards the end of that episode. And there's certain episodes where like other folks have more have kind of more of a pull. Like for example, this episode, Helly makes a really big appearance. This is the season finale of the first season, and so on. So you can kind of, this is kind of neat because the whole beginning of season 2, episode 1 is like just Mark. He's the only one speaking, and then you sort of start to see that the rest of the characters come into play. So anyways, so this is an example of kind of analysis that I could do with the with that transcript data. I also did a couple like sentiment analyses. So this was just looking at kind of different types of characters and how they were feeling. And so pulled the different words and mapped them using those different sentiment lexicons. And then this one, so there was an episode, I thought this was, so the series itself got kind of funny about some of their, so the whole thing is like about kind of corporate America or whatever, and one of the episodes, one of the characters gets this like binder of sort of like a review, and one of their critiques was that they used too big of words. And they were given a word cloud as like one of the ways to visualize this, which is kind of hilarious. So I decided to recreate this word cloud. So I pulled all of the times that this character spoke and made it into a word cloud. And then I did a couple things like, I removed the proper names from it. So did that and sort of see what kind of words that they're often using. And then did a couple other analyses like syllable counts and looked at kind of, maybe instead of multisyllabic words, what they really mean is that he doesn't use common words. And so this Fry 1000 word list is one that you can use to sort of, it's like the most commonly used words to sort of see if he's using uncommon words more than everybody else. And it turns out, like in general, I think a lot of people use weird words in this show. So there was not a ton to see there. I also kind of did this one where I instead of weighting by the term frequency and verse document frequency, or instead of just weighting by frequency, we could weight by this term frequency and verse document frequency, which sort of is like what words is Milchick using more than anybody else. So things like marshmallows show up, meantime. And then so I kind of found myself in this community of people also interested in both data analysis and Severance. And so Leopold, who is, a refiner of the quarter, said that we could use maybe, excuse me, the zip frequency of the word as opposed to the Fry approach, excuse me, that I had used. And so we did that as well and compared basically Milchick to a whole bunch of other characters to sort of see if the distribution looked different. And so I thought that was sort of interesting as well. This was, I think, interesting because his zip frequency distribution was actually different from everyone else's. So that was kind of the one that we saw some difference. All right. And then I also curated these audio data sets. So for example, there's like a part of the show is that these characters like go down an elevator, and it turns out the pitch that the elevator is playing like kind of tells a bit of a story. So I created this data set of all the different pitches. So that meant, initially that meant that I, kind of in the first season when I was trying to make this data set, there's actually someone on Reddit had started it. So that was what like initially kind of, I was able to use some of theirs to start. And then I don't know where they went, they disappeared. And so then I kind of kept it going from there. So at the beginning I would have to use, I had like a little ukulele tuner that I would sometimes pull up to try to do, but actually like pretty soon after I could hear it myself or I could like pluck it out on the piano. So I didn't have to like have my tuner ready. But that's what this is showing. And it turns out I have this grayed out because there's some spoilers and I don't want to share those in case people are going to see the show for the first time, but it revealed some aspects that were like not known at the time. And so that was an interesting theory driving analysis. And I also had this theory about the pitch of one of the actors' voices. So the actors are playing like two versions of themselves throughout the show. And I had this theory that maybe one of them was playing a different version than what we had revealed to us. And so I pulled kind of clips of this actor. So I recorded little clips of it and mapped it to kind of different dialogue. And then I sampled kind of from the episodes and then filtered to just lines that were at least kind of 100 characters. So I could like have enough to actually kind of do a little bit of analysis. And I then estimated the fundamental frequency through a short-term substral transformation, which is like kind of, I don't know, this was all stuff that I've never done before, but was able to figure out how to do in R, and then plotted to sort of show that this one that we weren't really sure about, it kind of matched one of the distributions better than the other. And I did a couple other little analyses there as well.
That's great, Lucy. I'm just letting you know you have like 10 seconds, 30 seconds.
Perfect. Okay, I think I can probably wrap up then. So there were some visual artifacts too, like where I could pull kind of IDs from the screen. This is another example. And I think these last slides are just showing where you can get the R package. So you can get the R package here, and then the slides were all made in Quarto. So that's what these were made, in case you're curious about that. Thank you.
Awesome, thank you.
Oh, someone said, where can I find your website? and repository. I will put that in the chat. So this, where can I send this to everybody? The slides are here, and the website for the main analysis is here.